Hello, welcome. So I've been rather sick the last, I guess it's almost been 2 weeks now. Yeah, so I haven't been producing any videos. So I just wanted to give myself a chance to recover. First got the flu, and then that is almost always followed by a sinus infection for me. So it's a long, tedious process, and unfortunately, I can't take any cold medicines because it messes with my restless legs. So yeah, I'm never very happy whenever I get sick, but it is what it is. Anyway, I thought I'd do a bit of a different video today, and I will be continuing the compiler series. Next videos are on the register allocation, and I want to do them justice, so I want to be well before I do those videos. So that's the delay on that. So let's talk about digilogic. And again, this is a code name for now. I don't know if I will keep this name or not. I figure it's fairly easily Googled, so maybe I'll keep it. I don't know. So one thing that I don't want to do in devlogs is talk too much about the future. I find it affects my motivation to do the things because I've already talked about them, and yeah, then it just kind of fizzles out. So I don't want to do that to myself. So pardon me if I'm not saying too much about the future and what my plans are with this, but I'm thinking initially something that would actually be really useful for me is just having a circuit diagram editor, specifically for iOS. I'd really like to be able to use it with my Apple Pencil on my iPad, and the existing solutions for that are not very good so far that I've found. If you know of a good way of doing circuit diagrams on iOS, let me know. It's got to be good though. So far, all I've found is just a drawing program where I just have to draw them by hand, which is not great. So yeah, and then it'll work on Mac as well. It will probably support Windows as well eventually, but the minimum viable product would be just these two for now. It will have probably this kind of feature set for now. And again, I'm trying to leave out any future things other than this one. I haven't implemented this one yet, but it's next on the list, so I feel like I can talk about it. Hopefully that won't cause motivation issues, but we'll see. And I don't have very much else implemented so far. It's heavily inspired by Issie, and here's the hub link for it. I'll put a link in the description of this video as well. So you can download that and play around with it to see kind of where I'd like to head. I won't be copying everything that Issie does, but yeah. And unfortunately, the technologies that Issie is built with, I don't want to learn. So I can't really contribute and make Issie better. Yeah. So it is what it is. And I kind of have different goals, and you'll see what I mean in just a second. So might as well launch into a demo. So this is what I have so far. I've got zooming, and I've got crude panning with just the keyboard implemented. I've got hovers on various different things implemented. I can select things by clicking on them, and I can move them around. And you can see that auto routing is supported, and it's surprisingly performant. So that's really awesome. I'm using libavoid, which, yeah, it's a really good library so far. It's C++, so I have had to do a little bit of C++, but for the most part, this is written in C. And yeah, I also have selection boxes. So I can move some parts at the same time, and you can kind of move it anywhere in there, and then you just click outside to change that. Eventually you'll be able to manually route wires, probably with some pinning mechanism to prevent them from being auto-routed. I don't have any idea how I'm going to do that yet, and you can see the auto-router sometimes glitches. I don't know what's causing that. But yeah. It's, oh, that's not supposed to happen. What is going on here? Huh. There's obviously still bugs in this. I've been playing around with this logic first because I feel like this is the hardest part to get right. And if I can get this right early, then it'll be a lot easier later on. So maybe I'll go into the code a little bit, and I'm not sure if this is going to be open source yet. There's a lot of ideas I have in my head about, various different things, but we'll see. But I can show you around a little bit. One of the big things is that I separated the core, which is just like the internal representation of all of the components and nets and stuff like that, from the view. And the view is like everything that you can see. So the view ends up having the same components as the core, but has things like positions and themes and stuff like that. So this would be the core circuit, and then the view circuit wraps the core circuit with the same IDs. So you can either look it up in the core circuit or the view circuit, and these will correspond one-to-one with the same IDs. So there'll be a component ID that's an index into this array as well as the core array. And then the UX is similar, except the UX doesn't need any view information. So it doesn't have the same mirroring that the other two layers have. But UX is where all of the user interaction is implemented. So I wanted to keep it separate from the view logic, like how things are drawn, because then it makes it easier to test. And actually, I can stub out the drawing completely. So in here, this is the interface for drawing. And at link time, I can either, there's one implementation of these draw functions here. Well, in main.c, if I can find it. Yeah, here they are. So in main.c, it actually draws on the screen. And in viewTest.c, it just actually puts a draw command into a buffer. And then later I have dump for the draw buffer that basically does pretty printing of it by kind of assigning identifiers to vertices and colors. That way in the tests, you can do asserts like this, where it just asserts that there was a filled rect and it was centered on V0 and it had color C0. I don't really care what the actual vertices are or the actual colors. I just want to know, okay, this filled rect is at the same position as this stroked rect and they have different colors. And likewise over here, these are the circles for the ports. And I want to know that they're drawn with the same colors, but in different positions than the other things. And that's all I really want to know. So I'm just using a pretty printer to abstract away all of the details that I don't care about in the tests. And that just makes it a lot easier to test this stuff. So in this, I'm drawing a more complex circuit, and I'm verifying that all of the things are drawn, and I'm verifying also the order that things are drawn, but I'm not verifying the exact positions of things because that could easily change. And I've already done some refactors where I've changed colors and stuff like that. And this has just saved me from having to change my tests as well. So there's that. So that's an important thing I feel like to do. I don't have any UX tests just yet because I'm kind of prototyping it. But once the prototype is a little bit more solidified, I'm going to have a bunch of UX tests that are going to be similar, where they don't test the exact details, but they do make sure that the interaction are happening the way I'd expect. And I can easily mock it out without actually having to hit keys on the keyboard or anything like that, because it's just passed in this input struct. So the input struct has all of this information about what happened in the input system in this frame. And then this makes it a lot easier to just set this up in tests and do verifications that if I click on this component, then this happens. And if I click on that component, then this happens. And if I drag, then this will happen and stuff like that. The other thing that I wanted to show was how I implemented the state machine for clicking. And this is actually mermaid code. And I just have mermaid.live running over here. And so this is the state diagram. It's just some markup that just says where all of these wires or all of these lines go. And I thought I could zoom. Maybe not. Maybe I just have to do it this way. Okay. All right. Hopefully that's large enough. If you're on a phone, it's probably not, but I can't seem to zoom in anymore. Yeah, no, it doesn't let me. If I turn this on, does it let me zoom? Yeah, sort of. Yeah, anyway, so these 2 points here are the same. I just didn't want to have a bunch of loops making the diagram more difficult to read. So the up state would be when the mouse button is up or released. And then when it becomes down, then it'll go into one of these other states depending on these other things. And I did get one comment that this seems backwards from what you would normally expect in a diagram like this, where these here, like the down and over component and over port and in selection, those are like Boolean flags. And then these are the states. I guess sometimes these are drawn the other way around, where the conditions for the transition are in the boxes and then the states are the lines. That doesn't really make sense for me to draw it that way. I'm used to these sorts of diagrams, so that's what I did. And then when I implement it in code, these are all of the Boolean flags that are on the transition lines. So I just separate those out. Some of them have to be inside of a for loop because I keep iterating until a state stops changing. So it may go through several states per frame. That just is a little bit more flexible. So I'm just keeping track of the old state and the new state. And I've got all of the Boolean flags that I'm looking for here. This one's a little bit special in that I have to check to see if the mouse is over or top of one of the components that's currently selected. And then I just have the state transitions, and it's important to keep the state transitions just state transitions and some if statements in it because it's a lot cleaner. So if it goes into it and the state is in the up position or in the up state, I guess, then it checks if the mouse is down. If it is down, then if it's in a selection, in other words, the mouse went down over top of something that's selected, then it'll go into the state of move selection. If it's over a port, then it'll go into click port, etc., etc. Some of that's not implemented yet. If it's over a component, then it'll select that component, and then it can immediately go into moving the component if you drag it, etc., etc. And I find that this is a lot easier to maintain than some sort of DSL. And in fact, you can kind of think of this as a DSL, but it works in any language that has switch statements anyway. And I don't have to relearn some DSL every time I need to modify this, because after a few months, you're not going to remember how the DSL works. And to try and relearn the DSL every time is painful. So in 3 months' time, when I haven't touched this code in 3 months and I start looking at it again, it'll be, to me anyway, abundantly obvious exactly what this code is doing. And hopefully it's more obvious to people that aren't used to this pattern as well, but I don't know. So yeah, with this pattern, it's very important that the switch statement that has the state transitions is separate from the event logic. The event logic is these Boolean flags. So that needs to be separate from this switch statement. You can't be checking anything other than just Boolean flags in here. Otherwise, it turns into a nightmare because you have a way too much noise. I mean, this is already like, I don't know, like 100 lines or something like that just for the switch statement. 240 to to 150. Yeah, so basically 90 lines just for the switch statement. So you don't want to be adding any more lines than absolutely necessary to this. Otherwise, it becomes really difficult to figure out what the state transitions are. And then in here, I've got the processing of the actions. So here I'm processing exit actions. So when the state changes, this is switching on the old state. So then it's leaving state up to some other state. So then I'm just saving where the mouse was in world coordinates rather than screen coordinates when it left the up state. So then I don't have to repeat this in all the states it could go to. And then now I'm switching on the new state that has just entered. So this is what happens when it enters the deselect state, for example. It clears the selection and removes the selection box, right? If it's selecting one, then it clears the selected components and adds just the hovered component to it, et cetera, et cetera. And then this is what happens every frame for these specific states. So this is outside of the for loop where I am processing all of the different states. So this is the code that runs when it's moving the currently selected items. So it's just going through there and moving all of them and updating the routing information for the wires. And then in here, it's drawing the selection box and updating which components are selected as a result of the selection box. So that's that. I think that's all I really wanted to show in the code was just this pattern. I really like this pattern. I think it's great. A lot of people either just do a bunch of Boolean flags, and then once that becomes unmanageable, which happens rather quickly, then they reach for some DSL or library or something like that that can help with state machines. I just haven't had any luck finding a library that I really like. And then the library will be completely different between different languages. So it's not transferable. And I find this technique is transferable. It works in JavaScript just as well as it works in C or Go, or you could probably do this in Rust, although I hear in Rust you can use enums for these sorts of things. So I don't know exactly how that would work. I'm guessing enums and match statements. I don't know. But yeah, I find this is my favorite pattern for doing state machines. And it's a lot easier to debug. And this is a cinch. To write some unit tests for this, I just have to pull these Boolean flags out or figure out how to calculate them outside of here. And then, or not even that, I guess, because I have complete control over where the input, like this input struct. So I should be able to just, move the mouse where I need it and stuff like that, and just keep calling this and getting the new state. So it's trivial to unit test this, whereas some other state machine libraries are major pain to test. So yeah, I think that's everything. I'm kind of rambling a little bit. So digilogic, I haven't decided yet how I want to handle like financing and whether I want to, charge money for it or anything like that. For now, I'm holding off open sourcing this just until I decide some of those details. As I've said before in some of my other videos, I'm not working right now, so it'd be nice to have some sort of income coming in. And so far, this whole YouTube thing has, this information is going to be out of date fairly rapidly, but so far I've made a little under $15, which for the number of hours that I put into that's like crazy, crazy, crazy below minimum wage. So, yeah. But in the future, I'm probably going to go back to work. And so if I go back to work, then things might change. I might be feeling more generous about this project. I don't know. On the other hand, it would be nice to have like some sort of backup plan where I can make, some sort of money doing something. And I figure like a product would be a good idea. This is the only product idea I've had that seems like it would be a good one because it would be something that I would use like all the time. So, I'd rather work on a product that I actually want to use like constantly. So And yeah, I would definitely use this all the time. So yeah, we'll see what happens. It's all up in the air. If you have any opinions on that matter, please let me know. You can either join my Discord, which link to my Discord in the comments below, or you can just leave a YouTube comment and let me know what you think there. I might do some YouTube polls in the community section. So maybe check the community section to see if there's any polls up for this project and see where people would like it to go. Yeah. So I think I'm just completely rambling now. I will let you go. So yeah, if you're one of the people that support me, thank you. Thank you very much. I very, very, very much appreciate it. But yeah, thank you very much for watching. I hope you have a great day. Bye.